Hello again. Yeah, this is going to be a series now on Chapter 5. Unfortunately, this is now week 5, and things that I thought that we kind of understood, which were covered in Chapter 5, obviously there were still a lot of questions and a lot of bad assumptions. So what I wanted to do was I wanted to kind of go through Chapter 5 again, go through the PowerPoint, and re-emphasize those things that we needed to cover. Anyway, so let's go ahead. And again, Chapter 5 is orthographic projections. Okay, so here's the objectives. What we want to do is we want to recognize and sketch the symbol for third angle projections. Remember, third angle projections is what we use here in the United States to project, as opposed to Europe where they use first angle. Okay, now those terms, we need to know them and understand them, but you know, for right now, I just kind of want you to understand, have the understanding of how the drawings are put together. Okay, so we want to also understand, okay, we want to sketch the top, front, and right side views of an object with normal, inclined, and oblique surfaces. We want to understand which views show depth of the drawing, showing top, front, and right side views. We want to also know the meaning of normal, inclined, and oblique surfaces. We want to compare 2D CAD programs with sketching on a sheet of paper. We also want to list the dimensions that transfer between the top, front, and right side views. And then we also want to transfer the depth between the top and right side views. We also want to label the points where the surfaces intersect as well. And we want to enumerate those so we don't get lost. Okay, so here's the understanding of a projection. And I'm going to kind of fly through this because these videos take a lot to compile, and so I kind of want to get the maximum amount of return out of the minimal amount of effort, I hope. And I don't mean to sound lazy. It's just I can only post 15 minutes a video per chunk, so I need to get as few chunks as I can so that I can not bore you guys really. Yeah, I just want to keep you guys enlightened, but yet I don't want you guys to fall asleep while we're watching these. So anyway, if we take a look at this part right here, the front view is shown right here, and that's the projection shown in this direction. Okay, I think we all have that. Okay, now if we take a look at this view right here, we can see that the front is in that projection, and then the right side is here, and the left side is obviously opposite that. Top, bottom, and then rear. Makes sense. So we have the six primary views, okay? And here in the architectural case, we have 6 primary views as well. We have the front, the elevations. We call these in the mechanical world the side views, but in architecture they're the elevations. And oftentimes in civil engineering we call them elevations as well. But look at this reference picture right here. Notice the front, top, bottom. We would never see the bottom on an architectural building. We would see the right side and the left side, and then the rear back here. Okay, let's go to the next slide. Okay, so if we look at this part again, we're going to take a look, and the author calls this the width and we call this the height. Start to learn these terms right here, because we're going to use those throughout the course, and you're going to use those throughout your career in this industry. Okay, so now if we take a look, we're going to go ahead and revolve the piece here, and we're going to revolve it, I guess it would be, if you're looking on top, you're going to revolve this clockwise. Okay, so as you turn, and finally you get to the side view right here. Okay, and then if we want to take a look at the top view, we rotate this down, okay, forward, so that you can eventually see the top view. Okay, again, this is the width, this is the height. Okay, and here all of a sudden we have the depth. So we have the height, width, and then the depth. Okay, here's an important principle, since we are now in week 5, but this was I forgot which week it was where we were covering this a couple of weeks ago. Here the author makes the fact that the front view shows only the height and the width of the object. Okay, remember yesterday's discussion, I was kind of like mixing and matching, saying, well, what if we dimensioned it from here? But obviously there's a better way, and that's here the author is mentioning from the front we can show the width and the height. That's probably where it's shown the best. Okay, and in the third view, which would be the side view, we could show the depth. Okay, we can show the depth is shown in the left side or the right side or the top, any of those, or the bottom view. Okay, now the way to understand projection, okay, that's a magic word there, projection, is that if I have a plane of glass, this is the pane of glass that your eyes see. This is a plane that your eyes see, okay? You have a 3D object behind it. When the rays come off of that part to a plane of your observation, this is what you see. Since we have two eyes, we see in stereo, so that's what gives us the ability to see depth. But for drawing purposes, we just assume that there's a plane that we're looking at, okay? And obviously, as the rays project, there's little dots that create the outline of that part. Okay, now, here's where we're having a little trouble. Okay, now we do the same thing with the top plane, and we do the same thing with the right plane. We project the lines out, and that's what the part looks like on the side view and on the top, okay? So here's the major important piece of information that you need. This is like fundamental right here, okay? That is the understanding of the glass box. So in order to understand the glass box, one way to understand is to view this. Let's read this here. One way to understand the standard arrangement of views on the sheet of a piece of paper is to envision the glass box. This is where a lot of us just, for some reason, I just didn't get it. Either you didn't review the material, or most likely I just didn't present it clear enough. But if you imagine this glass box, and let's say this box was a box of cereal. So what we do is, if this is the hinge point, if I unfold that, that would be the top view, and if I unfold this side this way, it would be the side view, and likewise on, say, this left side here would open up, and then if that hinge point way back there would open up, we'd see the back. So this glass box is the way we should try to understand how these views should be presented. Okay, now here's an example of that glass box being unfolded. Okay, and there we go. Okay, now you should always, if you have any questions, refer back to the page in the text where this sheet is shown to you. Okay, you'll find this on page 167. Okay, and here's a typical example of what your drawings should look like, especially at this level. Okay, front view, top view, side view, front view, top view, side view. And the way you locate the top view or the side view is you just send out really faint construction lines up so that you can find where these particular views coincide. Okay, so I think that's fairly clear. Okay, and there's a couple of ways of measuring. We can measure off of the scale here. Scale here, and then translate them back over. Or you can use your dividers. Or the third way is what I call the up, over, and then down, where all these lines are projected up so that you can get your shape of your piece. You have the width. Then what you do is you bring out some lines, some faint construction lines, and then draw a 45-degree angle. Wherever those intersect your construction lines, you then project down. Okay, and then these lines here off of the top and the bottom, if you project those lines over, they'll intersect, and the part will fall out right in front of you. Okay, so the necessary views, remember this, necessary views are typically your front, top, and side. There are occasions when the part is a simple enough part, like maybe in this case, where you may not need the side view. Okay, so here they're showing the front, top, and the side view. Here they're Xing out the bottom because we won't need that at all. The left is just the same as the right. It's a mirrored image. And then the back is basically the same as the front. Actually, he made a mistake here. The author made a mistake. Let's see. These lines, oops, let me go back. These lines here should all be phantom. since if you look at the back, all this detail is hidden if you're looking from the back. So there's an error right there. Okay, so here's two views of an object, and here the author is telling you the best way to show those objects. Okay, so if you remember right, I said if you have the first view, which is the front view, the best view to show next is the one that shows the longest amount of information. And if that's the case, then the height shows the longest amount of information here. So that's why you would have the right, as opposed to this poor version where you would show the top. Now that would show the shortest amount of information. Okay, here you have the longest amount of information off the front view, but here would you show the shortest amount. So that's why you want to pick those two. Okay, and let's see. Here's just one view. Now I'm going to let you think about this for a while. Why do you think we would just use one view? Well, the reason being is this is a rounded piece. Notice the diameter symbols there, and except for this end right here is square. I did it again. Hang on a second. Okay, here. So notice that the everything's round. This is square, and it's denoted right here with the square symbol. And we have a thread on this side. Okay, and it tells us what the length is. So it does us no good if we're looking at the side view or the top view, because the top view is going to be identical to this. So that's why we would have just one view. Okay, and then here the author goes through the choice of views, and you could see why, just intuitively, why this is the best, and these are kind of lousy views. Okay, don't think I need to go through that. Okay, third angle projection is what we use in the United States. Okay, so here's a little symbol that they use for third angle projection. Now, if you think about this, what they did was they went ahead and showed you the front view, and then if you open the little glass box, you would get this view on the side. Let's just kind of burn this in your memory, and we'll take a look at what the European standard is for the first angle projection. But again, here, let's take a look at our box. We have the front view, top view, side view. Okay, and here the author's given us the angles of the quadrants. Okay, I'm trying to think why we would need that. Okay, looking at this picture, the drafting this chose this to be the front view, which is okay, and it's up to you using your intelligence of how you want to depict this for the machinist. Okay, and then all of a sudden we swing up to the top view, and then they swing out to the side here, side view for the side view. Now the author is telling us that is a poor arrangement, and I mentioned this in classes because one, we're going to interfere with whatever information is going here, like a revision block. So if we swing it out from the back side here, we keep this area clear. So this is a preferred method as opposed to swinging it out this way. So if you, again, let's think of the glass box here. This is the front, this is the top, and here's the side. And this is your standard arrangement. Anything other than this is unacceptable. Okay. Now I'll let it go for week 5, but I will mark it down obviously if I see that any more past week 5. Okay. Now if we take a look at the first angle projection, this is what they use in Europe. Okay. So the way they show the first angle projection symbol is this way. Now let's compare this to what we had a couple of slides ago. See, that symbol with the smallest part over on the right hand side is now depicted over here. So what they do is they do this kind of wild swing. I'm not sure why they do that, but it doesn't seem intuitive to me. But I'm sure the Europeans will justify it. Maybe it's just the case that they do everything opposite that the United States does. So maybe it's, see, what they're looking at actually is they're looking at this view, but they actually swing it over here rather than just unfolding it out this way. So they almost pass through and show it on this side. Okay? It's kind of odd, but I mean, that's the way I'm sure it's worked for years for the Europeans, so I'm sure it's okay. Okay, so what we want to do is as we draw these items, we want to make sure that we differentiate our line work. Note the differentiation here, how the outside, anything with air behind it is shown heavier, and everything that is hidden is shown in a light dashed line. Okay. Okay, I haven't been a real stickler for this, but from now on, oops, went too fast. From now on, I'm going to really mark you down if we don't have the center lines. It's imperative that we have our center lines on any round holes or any round stock. Okay, so let's make sure that we do that. Basically, the rule of thumb is this. As we're progressing, learning through the text, our work should be improving. And what I've seen is it's kind of like just staying still. There are a few students that really have taken charge and kind of like charging out there and getting some great work done. But by and large, we're just not taking care of our hand lettering. We're not using our lettering guides, and we're not keeping to the lessons that we've learned. So everything builds upon each other. Everything's kind of like a Lego, you know, just builds upon each other. Okay. Now here we're talking about the precedence of lines, and I'll let you actually, let me just talk about that real quick, okay? So here the author is saying, okay, if this center line happens to coincide with a external feature line like this change in grade here, he's basically telling us that that line right here that represents this change, that has precedent over the center line. So I'm not going to show a center line there. I'm going to show the actual break of this grade break right there. Okay? Same thing here. Oh, shouldn't. It's a really sensitive mouse. Same thing here and same thing here. Okay? So since this line right back in here is that hidden line. So that takes precedence over the center line. Okay? Now here's center lines continued. If we have, most of the time in mechanical drawings you don't have the center line symbol, but in civils you do, and in architecture you do as well. And this is the standard symbol for that. Notice all these center line depictions. So this is a page that I would tag. So if you have any questions on how to label center line, you can refer back to this page. Okay, and here's some oblique surfaces, okay, and inclined surfaces. Okay, so here these two planes are normal surfaces. They're parallel to each other. And here's an instance where this plane is not parallel to this inclined surface. Now let's get this term correct. This inclined surface. And here's an oblique surface it's basically an inclined surface, but it's oblique because it's not really parallel to any plane. It's just kind of cutting this notch here. Okay. But let's take a look here. That if on the side view, and it makes sense, and we know this intuitively, that this face here eventually becomes this line if it's turned on its side. Now this line turns into a point if I'm looking down at that face. So if I'm looking down on the top view, this line becomes a point right there, point 1. Okay. Okay, the author mentions here that if an angle is normal to the plane and a plane is parallel to the plane of projection, it will show the true size of the plane of the projection to which it is parallel. So what he's saying here is that if this is a 45-degree angle, and if I was to grab my 45-degree angle and set it at 90 degrees, if I look at the front view of this, it will be a true 45 degrees. But here, yeah, it looks like it's 45 degrees. It looks like it's the same shape, but since there's a inclined surface here and it's laid back, that will not be 45 degrees. Okay? And the same thing here, if this is 60 degrees, inclined plane, you'll see this is going to be the true length, but it lays back, so it will not be the true length. Okay, and that's kind of intuitive. That makes sense. Okay, so one way to interpret the process is to interpreting a view. Is to reverse the process. So typically, what we do is we see this. Well, actually, maybe one piece, and then we have to interpret what the isometric looks like. In some of our exercises, we've actually taken this view and created the projection views here. So if we were looking at this isometric view, we would then project out what the front view is, project out what the right side would be, and then the top. Okay, so that's kind of like reverse engineering. Okay, so one of the best ways to kind of figure out how things work really is to create a little model. And when I was taking drafting, I had a little block of clay. So I would actually cut the clay and kind of shape out the model the way I would think it was being represented. Now, some of the complex, as you go through your drafting courses, some of the models will become more complex, and you'll need to do that more often. But for the simple shapes we have now, it's not that big of a deal. But I think you would stand to gain if you went ahead and maybe later on in your drafting career got a chunk of clay and was able to dice it up. Anyway, okay, so that seems to be the end of this chapter 5. So hopefully I went through it succinct enough, but yet covered everything that we needed to cover. Okay, the PowerPoints and the lectures are no replacement for reading the text. Okay, and I think that's what's our problem, is that we're not getting into the text. So my next section is going to be a refresher on something we just kind of glossed over real lightly in class. So, and that's going to be on actually creating sides using the compass and triangle methods. Okay, so I will do that chapter right now and post it up as well.